So changing landscape of decision making, impact artificial intelligence on oil and gas industry. So just I wanted to say why I chose this topic, right? Because I know it's a generative AI was the overall title for this conference. But then I thought, okay, there are a lot of things must be happening in the generative AI side. Let me step back and see how the AI is affecting the oil and gas industry. And many of you may be new to this one. So I thought, let me share my thoughts, my company's thought with you, and just leave it there to see how can you people contribute in this one. Okay? So some sort of I'm trying to add, is not a perfect agenda, but overall my talk will be sounded around first I'll set the context, and through the context I'm also going to say why we need AI in the oil and gas industry and how it will help us. And then we'll see what AI is there in oil and gas industry. And towards the end, I try to, basically last 2 points we'll cover together, some workflows I will be presenting. Okay, so first thing, look at this picture, right? Typically, can somebody say what is this left side picture especially? I want to say, can you say something about this picture? There is a reservoir, but we are not there yet. Yeah, couple of things. So yeah, depth. So see what is happening, right? Is a seashore. This is basically blue one is a seashore, right? And on the sea, what is happening? The oil is somewhere trapped here. Now what we are trying to do, we want to identify where are the oil reserves, right? Now it is not very easy to find just like that looking at. So what typically companies do, like consultancy company like SLB or one of my colleagues here, there's Halliburton, they take huge equipment in the boat, or if it is land, it is through the truck, and they basically send the sonar waves. So like typically what you do in with sonography, right? So that you can see inside what is happening inside the Earth's crust. Okay. Now you send the wave, but you have to the reflected waves. You want to collect it, right? So that is why you have a grid. Basically, you have hydrophones, basically which receives these reflected waves. And typically, the hydrophones are spread across kilometer by kilometer. And what happens once you get those reflected waves? You try to do some signal processing, and what you see is the left side image, seismic image, what you call. And basically it tries to say what is inside. As she introduced it during the talk, all geologists or petrochemical experts, they look at this image and try to estimate, basically they try to analyze this image in traditional way. And what they do they basically come with their analysis and says that possibility of the hydrocarbons. Okay, we'll see in the next. Okay, so this is a typical image. So first thing, when you want to drill a well, and what you have to do? You have to find the hydrocarbon reserves, right? But the different way they do it. You would like to know what are the formation boundaries, right? It's just not like that. You go and say, oh, this is where we'll start. But you should know the formation. Like this type of lithography is there. You have to drill properly, and then. But to do that, you have to understand what type of layers are there. Correct. The second one, typically if it's in the sea, if you're drilling a well in the sea, and if you want to say put the platform, you should know where the actual sea floor starts, where sea ends and actual floor starts, right? That is what is the sea floor detection. That is what I'm saying here. Comes here. Now, very important thing, typically reservoirs are around fault lines. Okay, so first thing what geologists do, they look at the fault lines and then start analyzing that. Hence, the problem which you are trying to solve, geologists try to solve, is this one. So find out the faults, okay, and also the colors are showing you the boundaries. Now, typically what is happening, when geologists get this image, typically he spends a lot of time, maybe 3 to 5 months analyzing the image, because this particular image is beautiful, looks beautiful. It's not this ideal image. What happens, a lot of noise, and these people do a lot of analysis through this noisy image, and then basically decide what type of formation, where are the faults. And this entire time taken will be around 5 to 6 months. So and then you start drilling the well. That takes another 2 years. So once survey starts, and by the time you get the well, production starts, almost 3 years. Now, what AI will do? The one thing AI can do will be, can we sort of minimize this time, the turnaround time, what you call the product, can we improve the productivity? Here we are not talking about replacing geologists by the AI tools. What we are doing, we are saying that can AI tool aid the geologist and minimize whatever time is spending here. So that is the first problem we are trying to solve. Okay? The next one, this is a, now consider, see basically this from oil survey to actual production, a huge cycle. So I'm not going through the entire process, but few things I'll keep in front of you, and then you decide like how can you apply RAG, AI, and take it forward. Okay? Okay, another problem which I'm trying to share with you, you feel that is quite common in medical or any domain, manufacturing, but is equally important in the oil and gas industry. What happened is, if you look at, say, oil industry sort of 100 years old, right, around 30s and 40s, people used to do manual, everything manual. After drilling, whatever information they used to get, they used to put into document. All of the typewritten, or it may be handwritten, whatever may be possible. Over the period of time, yeah, then Word came, then everything started improving. Last 10, 20 years, whatever data we're getting is now available in digital form. But if you look at these oil and gas industries, from 1930 to 1990, of course, in 60 years, lot of data, very useful information is available in a well. This is a typical well completion report. Basically tells when well drilling started, what are the issues, how was the non-performance performance time, how many times like you faced the problem. So lot of these reports contain a lot of information and ethology. And what happens if you make this information available to the today in drilling, what can happen? You can do a lot of things. For example, whatever event happened, unwanted event, that you can take care. So for doing that, we want to understand the document's layout. And that is what we are doing. The first thing is, okay, some sort of here, we want to understand what is this, correct? We want to find the layout. The second is, this is very useful information. This gets a meta information. For any document, we get a lot of meta information here. And using this meta information can be useful for the carbon sequestration, to understand abandoned wells. Can I use the carbon? Can I sequester it? So that is why this is very important. Okay. This is another important aspect, right? Because what happened, when you start drilling the well, you are doing a lot of measurements. And that measurements basically stored in a graphical form. And basically this graphical form, now we want to reuse it. So extracting this information from graphical form is another challenge which we are trying to address. Okay. So then it is typical tables, right? Any document will contain the tables. So here also you are getting the tables and you would like to extract it out. Now let us see. And then typical text. So from text you want to extract it out, your information. So given the document, you want to understand there are different entities, and then you have to extract out the lot of information. Yeah, one can argue that, okay, this has been done in using NLPs, but there are certain issues which we want to understand, correct? And what makes it challenging, especially in oil and natural gas. Let us look at this. This basically talks about the challenges which you are facing. The first one is the variation in the documents. So if you look at the documents, for example, my company will put a document in a different way. Petronas will put it, say, other oil company will put in a different way. Halliburton will keep in a different way. So and this data may not be available easily. So we have to think how to address this problem, correct? The second one is the skewness. These are old reports, right? And old reports, what happens? You scan it. First you write the report, you then scan it and combine together. And how the scanning happens. So definitely there are challenges like skewness. This noisy images will be noisier. Then, Okay. So another important issue is the handwritten characters. So as you know, people go and put their expert comments, and you have to deal with that. When especially developing the machine learning algorithm, it becomes a noise, truly noise. And last one, which is common to both seismic and the documents, or for any problem in the gas nozzle. So subject matter experts, each this table or in his own way. Okay, one can say that I'll put, for example, here, right? Subjectivity labeling I'm talking about. One person can put a bounding box for entire thing, another put a bounding on another. So labeling becomes a problematic. Then the same figure is basically represented by different SMEs in different way, and that sort of creates a lot of issue. Now, what should we do, correct? So first thing, what I'm trying to do. So you understood, right? It's typical problems which are facing in the oil and natural gas, and basically it establishes that yes, AI is a way to go. Then what we started doing now is addressing some of these issues. Okay, the first issue is we want to understand what are different entities. Okay, given the document, I would like to know what are different entities. So that is what we are trying to address. So this is a typical workflow. What happens is you are given a document of 1,000 pages. We would like to know what are the different entities. For example, I want to know how many tables are there in the document, and can I classify those tables? Then how many figures are there? Can I classify them? Then I want to find out certain attributes. From where can I get it? So that is what we want to do. So typically, what happens? The documents goes through this workflow. First, the pre-processing model basically tries to correct the skewness and all those stuff. Then there's object detection model, and then post-processing. Basically, post-processing, we use it for the correcting the bounding boxes. And once that happens, the output is available. Correct? Now, what we do, next part is, we look at the, this is typical results showing. So we did on extensively, thousands and thousands of pages, and this is a snapshot of our results. Okay, so once you finish that, once you identify different blocks in the system, the next thing what you would like to do, you would like to start extracting the information. So as I pointed out, there is what is known as raster images. Basically, there is a graphs embedded in the document. I want to get that information out in digital form, and this is the first problem we solved. So so typically what happens here? So first of all, you have to identify this page. Then there is a meta information. So you can see this meta information. You have to extract it out. Then you have to extract out this colored information and digital form, and get into digital form, and there is another information. So basically shows the lithography level, and that should be put in a text format as a function of what you call depth information. Now, the multiple things are happening, right? First, you have to say what are the meta information. You extract it out. You extract out the digital information, combine them together, then the results will be available to you. And that is what is essentially shown in the next page. So this shows the way algorithm works. So I will not get into this one. So we have two algorithms. One is where user can go ahead and sort of give the inputs, and machine can extract it out. The second one is completely automatic. So you give thousands and thousands of pages. It goes through the entire process. You separate out the log headers, then you segment out the curve, digitize it, and that it will be sort of ingested into database. Now, so this is a small app we have released to our internal customers. So some of the few customers, they are using it. Okay, so few results on the raster segmentation. So basically what you are doing raster segmentation means you are trying to identify what are different, given the document, what are different elements are available in that particular graph. So that is what the raster segmentation. And next step is, once you do the raster segmentation, you get the curve plot part, and using the machine learning, deep learning based technique, we are trying to extract out the curves information. So and that is which is available in the digital form. Next. So this is about graphical part. Now what happens, in fact, many times the information is hidden in the paragraph, hidden in the tables, forms. So now what we want to do, we want to bring that information together. So the particular problem statement tries to address this one. So what we are trying to do, given the multiple reports and given the certain entities, idea is can we extract out the common information and push it into database. By doing this, we are doing two things. We are making the information available to the user, and also we are enriching the existing database. So because of that, we were able to create the golden records. Okay, so these are the few results. For example, what we are doing here is a particular, this one of the 598 pages. And what has happened is for example, latitude or longitude information is available in the multiple pages. We extract it out from each page and then basically put in a JSON format. And this JSON format is basically given to ingestion pipeline, which ingests data into data. So once you establish all this stuff, what you are going to do, correct? Now, the multiple things should happen. First part I'm going to show, what you are doing, you are triggering a semantic search. Now the entire data is available in digital form, and we have our own search engine, which is sort of a hybrid search engine, basically based on machine learning and also lexicon search. So we are triggering, and this is the in-house built our search engine. So what it does, it allows user to, for example, query the data, saying that give me wells in particular basin. Can you tell me about the oil produced in the system, say from say Q1, Q2. So what happens, whatever information so far we ingested, this search engine goes, basically converts into proper Lucene query, and then we are able to get it and display to the user. Now, once you do this one, so far we are able to do multiple things. Next thing is, what are the challenges we are facing, correct? One is the scalability. So biggest challenge we are facing is the scalability, in the sense we are able to scale it. But now, all these algorithms are based on the, what you call Google or cloud-based systems, not Google Cloud, Azure, and actually it's a cloud agnostic system. So many customers are on-premise, they don't want. So what you are trying to do, we are trying to see how can we deploy in their system. So that is a challenge we are. Then another is the cost, because most of the things are based on the GPUs, and our people are our customers are quite sensitive to cost. So another issue that we are trying to address. So probably with that, I think I'll just leave it. Definitely, today's buzzword is Gen AI, and we are also trying to address some of these projects using the Gen AI. So what you are trying to do using Gen AI, basically, and RAG environment, we are enabling the semantic search, and then from back, we are trying to connect multiple our simulation engines, multiple analysis engines. The few are, like example, Petrel. Some of the people who are in the petrochemical, they may be knowing. Then there are certain Symmetra, which can be used for the simulating the network flows. So those are things we're trying to connect from the back end. So work is in progress. Maybe next time when we meet, I will have more to share with you. Okay? With this, probably I'll stop here, and I'm open to any questions.